Just getting ready for live streaming to be effected. All right, so that means we are on YouTube and we can hit the road. Okay. All right, so good evening. You're on to Mamu with Jarvis, and this is our midnight sun arrangement. Today we'll be looking at a topic. I deliberately didn't want to write the topic there, and I'm going to write it on the board now, so you get to see what we'll be covering. But for those of us who are joining with the Zoom, also take note that we also are airing on YouTube. We're airing this on YouTube, so you can just go to look for Mamu with Jarvis on YouTube, and you can watch the live stream as we have it here. Today we'll be looking at a very interesting topic, and we'll call it indices. Indices. All right, so get your book, get your biro, and let's hit the road on indices. Okay. So as is the format I've taken for this course, so I can already see people already connected using their YouTube. So I would like you, for those of us who are watching through YouTube, to please drop a chat and then perhaps tell us where you're watching from, whether you're watching from Nigeria, whether you're watching from Rivers State. Just give us an idea of where you're watching from, so that it's a feedback I need to see how well our work is going. All right, so as is the protocol for this class will cover grade 10, 11, and 12. Grade 10, 11, and what? Grade 12. 10, 11, and 12. We'll be handling indices, and it's a NECO WAEC level. It's a what? NECO WAEC level. So I'll be trying to hold those who are just coming into 10 and holding them together with 11, and then trying to see how I can push those who are already in 12 to prepare for their WAEC examination. So everything we're going to be using today are all WAEC question papers, all WAEC and NECO question papers cut across from different years. So the protocol is this: I'll write the question, and I'll be dropping key points on the right-hand side of my screen to help you remember what you ought to do. So we are starting right away. I will start our work by looking at which one is this? This is WAEC GC 2019, WAEC November-December exam 2019, and it's an OBJ question paper. So I'll pick the questions here that are related to indices, and then we'll solve. As I said earlier, I'll be taking note of certain ideas that will help you solve other problems as we solve along. So let's go. We start by looking at question number 4. So I'll just write WASEC 2019 November OBJ question. We'll start with question 4. And this is what the question wants us to do. Question 4, it says, simplify 1/27 times 3 negative y, 3 raised to the power of negative y is equal to what? 81 raised to the power of 2y. Let's start by reminding ourselves that the whole matter of indices starts with your understanding of prime numbers, and to be more technical, prime factors. So when I give you a number on the board, the first thing you need to do is to try to decode what the prime factor is. So what's the prime factor of 27? And what's the prime factor of what? 87. That's what you should do. Now remember that an index will suggest how many times a number is being multiplied. So if I say 3 cubed, it will mean that 3 is multiplied 3 times. That's the concept of index. 3 cubed will mean 3 times 3 times 3. So let's come back to this and look at this. Look at 27. 27 will mean that 3 is multiplied how many times? 3 times, and we can check that. 3 times 3 is 9. That's 2 3s I've used. 9 times 3 is what? 27. That is 3 3s I have used. Times. Now in indices, we can use a dot. Dot is another way of showing multiplication. So I'll say dot 3 raised to the power of negative y is equal to, now look at 81. 81 will mean that 3 is multiplied how many times? So I test. This is 9. 27. And what? 81. To make yourself fast and to get on with good practice, you can use your calculator to check so that you'll be fast. But while using your calculator, you must ensure that you are not just using it to make the calculator do all the work for you, right? So with that, this becomes 3 to the power of 4, all raised to the power of what? 2y. All raised to the power of what? 2y. Now, let's deal with this part. Remember that if I say 1 over a raised to the power of n, this will mean that the n is what? Negative. This is like, say, the reciprocal of a raised to the power of n. The reciprocal of what? A raised to the power of n. So we write this in this way or this way. So a raised to the power of negative n is the reciprocal of a raised to the power of n. And that's the knowledge I will bring from here to this point. And it becomes what? 3 raised to the power of what? Negative 3 times 3 raised to the power of negative y equal to, now watch this. If I have a raised to the power of 4, or raised to the power of a, or b, let's say b, or raised to the power, or let's use x is better, or raised to the power of y, it means that a raised to the power of x is multiplied y times. So because of that, we would say that a is raised to the power of what? X, y. A is raised to the power of x, y times. Let's take a practical example. If I say a raised to the power of 2, or raised to the power of 3, this will mean a raised to the power of 2 times a raised to the power of 2 times a raised to the power of 2. A raised to the power of 2 multiplied what? 3 times. Now, 2 plus 2 plus 2 is what? Is 6. So, go back. It means that all I would have done is to say what? 2 times what? 3. And that's what we're using here. So this becomes what? 3. Oh, sorry, is that an equation? Oh, sorry about that. That's a very big blunder I've made. It's an equation, so I wouldn't put this way. Equal to 3 raised to the power of what? 8y. Number times number letter. This is a number letter. A number times a number letter will give me what? A number letter. The order in which we write is this. Number before letter, right? So that's settled. We look at this. Dot will suggest that we are multiplying. So that will be negative 3 plus. If you multiply numbers, you are adding their indices. If you multiply numbers, you're actually adding their indices. Right? So this becomes what? Plus negative y equal to what? 3 raised to the power of what? 8y. So what do you do? What do you do next? Now, this is 3 raised to the power of this. This is 3 raised to the power of this. So we can simplify and say what? Negative 3. Because the bases are equal, we can equate their what? Their indices. If the bases are equal, we can equate their indices. Some teachers will say cancel, but technically, once the bases are equal, you can equate their indices. All right, so that will be -3. Negative times positive times negative will give you -y equal to what? 8y. What do you do next? Remember that this is now an equation. And the standard practice for an equation is to keep the unknown on one side and the known on the other side. Some rules can be bent, others can be broken. You don't necessarily have to keep the known on the right-hand side. But towards the end of the problem, in finishing the problem, you are expected to keep the unknown on the left-hand side and the known on the right-hand side. So from here, this is a servant going to meet his maker. So this becomes what? -3 equal to 8y. Because this is negative, it becomes what? Positive y. And this will be -3 equal to 9y. At this point, we can rewrite. If left is equal to right, this right is equal to left. So I can now write y equal to what? -3. What do? I divide both sides by 9. If you're comfortable with that. And it means that y will be equal to what? -1/3. And so that solves question number 4 of this year. Right? So let's give us a minute or two to catch our breaths. And then we move on. I hope the grade 10 students in this class are finding the things interesting. There are some things you have learned already. By the end of this class, I'm going to attach some links to previous videos I've done. I've done extensive work on this. I'll attach video links to this so you can go back and take pains to watch them step by step. Okay. So while you're sorting that, let me put the second question for us to solve, right? Now, the next one is question 20. And it says 16/81 all raised to the power of -3/4 times 100/81 all raised to the power of what? 1/2. Okay. All right, sorry about that. Okay, so if we're done with that, can I get a yes? Can I get a yes? Can I get a yes to that? Maybe from 1 or 2 persons. Thankfully enough, this is recorded. So after the class, you can always go to YouTube to look for, under my playlist, look for live streaming. Go to my YouTube channel, Mamu with Jarvis, look for live streaming playlist. It's there. You can always rewatch. Even immediately after. That's the beautiful thing we take. Immediately after the class, you can go back and rewatch. All right. So we look at this problem. It says 16/81 all raised to the power of what? Negative. Take note of this. This is -3/4 times 100/81 all raised to the power of half or 1/2. Now, in solving this problem, when you're solving this problem, especially if it's an exam setup, you need to look out for what you can see first. I always tell students, what I see first may not be what you see first. Look at this. What is half? Half in index means what? Square root. So this is a part you can easily take care of quickly. That's one. Now, negative index means turn the content. Negative index means what? Turn the content. Make the numerator denominator and make the denominator numerator. So if you've gotten that, this will simply be what? 81/16 all raised to the power of 3/4 times Now, 100 over 81, 1 over 2 means square root. So just put a square root there. Now, if I were taking you this in grade 10 and you use this method, up to now, I would say you're wrong, because at grade 10, we are testing your knowledge of the principle of what? Indices, right? But if you do this now at WAEC level, you're very correct. So what would this be equal to? This one I can easily take care of. 100 will become 10, 81 will become what? 9. How do I take care of this? Now, look at 81 very well. Look at 16. What is the prime factor there? Remember that the whole concept of prime means that you're looking at numbers like 2, 3, 5, 7, 11. These are prime numbers. So I look at 81. The prime number I can easily see there is 3. How many times will I multiply 3 to get 81? So I start 3 times 3. That's 2 I've used. Times another 3, 27. Times another 3, what? 81. So I'm using 4. So I know that I'll use 4. All over, I go to 2. 2 times 2, I've used 2, that's 4. Another 2, that's 8. Another 2, that's what? 16. I have one small student behind the scene trying to learn too. Right, so that's 2 raised to the power of what? 4. Everything raised to the power of 3 over 4 times the square root of 100 is 10, and the square root of 81 is what? 9. So I've taken care of that. The next thing I want to do, at this point, there are 2 ways I can go. I can separate. If this is affecting this and this, it means this can affect this and can also affect this. So let's go with that approach for now. This will affect this, and it will also affect this. Are we seeing that? So at this point, for your knowledge of what? Fractions come into play. This 4 is like say 4 over 1. And then this is like going into Ant-Man and the Wasp, Quantumania, is that not beautiful? So when that movie comes out, you get to see that this indices is like quantum, it's like quantum city. All right, so this 4 will cancel this 4. Okay, don't forget to put your times 10 over 9. This 4 will cancel this 4. The other is that numerator will always cancel denominator. And if that is gotten right, you will discover that this 3 raised to the, this will now be 3 raised to the power of 3 over 2 raised to the power of 3 times 10 over 9. What would this be equal to? Now, for me, at this level, I won't want to confuse you. Remember, this is OBJ. If it's OBJ, there are other shortcuts you can take. But I'm working the assumption that you saw this as a theory question. Now, the next thing you do is to say 27 over 8 times 10 over 9. You can cancel out. You can cancel out. Here, 1, here, 3, here, 4, here, 5. So what do you have? 3 times 5 over just 4 times 1. So my answer becomes what? 15 over 4. 15 over what? 4. And that takes care of that problem. That takes care of that problem. So I'll give us a minute or two to catch our breaths while we get ready for the next problem. I think there's still one more from that year. Let me confirm. There should still be one more from that year. Yes, I said there was one more from that year. That's question number 14. Question number 14. Question number 14 says 1 over 9 all raised to the power of y minus 1 is equal to the square root of 3. So that's the next question we'll be looking at. 1 over 9 all raised to the power of y minus 1 equal to the square root of 3. I hope I'm not too fast today. I got the feedback from my chat saying I should calm down. So sometimes when this thing is sweet, your body becomes very hot. All right, this is why. Okay, so let's try to proceed. Now, the first thing you need to do is to take 9. What is 1 over 9? 1 over 9 means the reciprocal of 9. So I'm going to write this to be what? 9 raised to the power of minus 1. And this minus 1 will now multiply y minus 1. This negative 1 will now multiply what? Y minus 1. Equal to, what is square root? Square root in indices is what? 1 over 2. Remember. So square root in indices is what? 1 over 2. So this will be 3 raised to the power of 1 over 2. Now, what is the prime factor of 9? It is what? 3. So I can say, let me open this first. For those of us who may know, so I'll say 9 raised to the power of what? Negative y plus negative times negative will give me what? Positive plus 1 equal to 3 raised to the power of 1 over 2. Okay? So what's the next thing I'll do? Let me, for consistency's sake, let me stick to this. What's the next thing I'll do? Look at this. This 9 is 3 raised to the power of 2. This will be 3 exponential 2 into what? Negative y plus 1 equal to 3 raised to the power of 1 over 2. Remember, we said that if the bases are the same, their indices must be the same. So if that knowledge is got it right, I'll say this will be 2 into negative y plus 1 equal to what? 1 over 2. All right. At this point, I will divide both sides by 2. I will divide both sides by 2 or multiply both sides by half. Please, to divide both sides by 2 would mean to multiply both sides by half. They mean the same thing. Dividing both sides by 2 and multiplying both sides by half are technically the same application. So I will choose to multiply both sides by half. And if I do that, I would have cleared this one away. So I'm going to have negative y plus 1 equal to what? 1 over 4. Notice that I'm not in a hurry. I'm not in a hurry. I'm in an exam setup and I'm working as I can remember what to do. Look at this. Now, for every equation you have solved or you're going to solve, the coefficient of the unknown must be 1 and not negative. You may want to write that down. For every equation you solve in mathematics, the coefficient of the unknown must be 1 and it must be a positive. So if you have locked that to your imagination, it means that you need to look for a way to send this man to become what? Positive. And the fastest way to do that is a slave. I mean, he needs to become a king. So I'm going to take him to become a king here. And I'm going to bring this man to become what? A slave. So I'll start with what is left on this side, 1. I'm going to make this man a slave. I'm going to make this man a king. So what do I have? 1 minus 1 over 4 is what? 3 over 4. And that will be equal to y. 1 minus 3 over 1 over 4. Sorry, 1 minus 1 over 4 will be 3 over 4, which means that y is simply what? 3 over 4. And with that, we have cleared this year's questions. Right? So I'll let you catch your breath while I get the next set of questions. All right, so let's get ready for the next one. Okay, the next one is from WAEC June examination 2014. So it will be WAEC 2014 June objectives, and then it's question number 35. Question number 35. And this one looks very interesting. Now it says the square root of 8, square root of everything here, 8 raised to the power of 2 times 4 raised to the power of n plus 1 all over. Please, the square root sign is covering everything. The square root sign is covering everything. All over 2 raised to the power of 2n times 16. Right, let's get that in order. Right, okay, so that's the question we are told to handle. 8 raised to the power of 2 times 4 raised to the power of n plus 1 all over 2 raised to the power of 2n times 16. All right, so at a glance, the question looks very big. At a glance, the question looks very big, but it's a very small one to handle. So remember I said that the basic understanding of indices is in the matter of the prime factor, the base. If I write a number like this, a raised to the power of n, this is the base, this is the index, so base and index. So to handle indices properly, or properly as it were, you need to ensure that the base you're working with is a prime where possible. So that's what I'm going to do here. So this will be equal to the square root of, I'm going to work on this. 8 means 2 multiplied 3 times. So this will be 2 multiplied 3 times, or multiplied twice, because it is 8 squared. 8 squared means 2 multiplied 3 times, that is the value of 8, everything multiplied 2 times. Now, times, what is 4? 4 is 2 multiplied twice, so that will be 2 multiplied twice, multiplying n plus 1. All over 2 raised to the power of 2n. I don't have an issue with this one. Times 2. What is 16? 16 is 2 multiplied 4 times. How do I know that? 2 times 2, I've used 2, that's 4. I use 3, that's 8. I use 4, that's what? 16. All right. So that is 2 raised to the power of 4. Now, because I'm not assuming, I'm taking it little by little. I will take on another step. This will be 2 raised to the power of 6 times 2 raised to the power of what? 2n plus 2. I'm opening this bracket up. Divided by, I don't take care of this. This will be what? 2 raised to the power of 2n plus 4. Are we seeing that? All right. Now, I still have some work to do on top. Remember that if you multiply, if the bases are the same, now I'm bringing another very important idea. If you've learned the laws of indices, you have been told something that the laws only work when the bases are the same. So if the bases are the same, you can add their indices. So if you are multiplying, you can add the indices. If you are dividing, you can subtract. So with this, I'll simply say 2 raised to the power of what? 6 plus 2, that will be 8. Plus what? 2n. Notice that I didn't say 2 and 6 plus. Sometimes all those things are unnecessary work. We already know that they are multiplying. And as long as they are multiplying, it means that at the index level, it should be what? Adding. All over what? 2 raised to the power of what? 2n plus 4. Now, this is where you need to be very careful. This base and this base are the same. What is connecting numerator and denominator is what? Division. So when you divide bases, you are actually subtracting their indices. So at this point, I'm going to have the square root of what? 2 raised to the power of 8 plus 2n. Now, the negative will affect 2n and 4. So it will be minus, bracket open, 2n plus 4. This is where a lot of us will make mistakes. We will then assume that the negative is only affecting this one. No, it's affecting this and this because they are all in the denominator. So with that, I'm going to have that this will be equal to, so let's come this way. Let's come this way. I think we're going to need a lot of space here. So with that, this will now give me what? 2 raised to the power of n plus 2n minus 2n minus 4. Remember that the negative will change this to negative. I will also change this to negative, right? Square root, don't forget that. And this will give me what? 2n minus 2n will give me 0. 8 minus 4 will give me what? 4. And this will give me the square root of what? 2 raised to the power of what? 4. Now, remember that this square root means what? Half. It means the index is what? Half. So I can simply say that this is equal to what? 2 raised to the power of 4 or raised to the power of half. And what is that? And that will be what? 2 raised to the power of 2. What is 2 raised to the power of 2? That is 4. And we have solved that question. So you see that it was quite, it looked very big, but it's nothing. It's one of those questions we call big for nothing. It's just big there, but there's nothing in it. All right, I think that was the only question in that year. So let's get another question paper and see how others would go. Let's see, do we have a chat? Sorry, 1 minute. Okay, sorry about that. Okay. All right, so let's run over this one more time because I'm getting a feedback that it was quite fast for some of my learners. So let's go over. Look at the question. Your first objective is to work with what? Your prime numbers or prime factor. 2, 2, and 2. So at this point, it will be 2 raised to the power of 3 multiplying 2, and 2 will multiply this. At this point, we are adding. When you multiply bases, you are adding their indices. And that's what I did here. Now, at this point, you are dividing. So what do? You are subtracting their indices. But the negative will affect this and this. And at this point, these two will clear out. So I'm left with this. Square root means what? 1 over 2. And that's how I got this to be to the power of 2. Some of us who want to be smart can use our calculator. 2 raised to the power of 4 is 16. What's the square root of 16? 4. You can do that. Nobody will penalize you. Right. All right, so I'm going to clean off everything and then we'll try to solve this one. This one is a theory question, so it's going to be very, very interesting. All right, this one says, this is NECO. I always like their questions. NECO 2003. Question number 4B. Question 4B theory. NECO 2003, question 4B theory. NECO 2003, question 4B theory. So how does that work? Now let's see. The question says simplify 125 a to the power of 5 and b to the power of -2. All over, the square root is covering everything. 45 a to the power of 3 and b to the power of what? 2. So this is what the question is seeking to address. This is what this question wants us to do. And here again, this is a very simple question. It's a very, very simple question. So let's see how we handle this. Now, I will not bother about the square roots. I'll worry about these numbers here now. So look at it. I'll start by saying the square root of 125. Please watch what I'm doing now. Over 45. Watch carefully. A raised to the power of 5. Now, I'm picking them individually now. I'm comparing numbers. Remember we said numbers and letters. So I'm picking the numbers now. 125 over 45, they are numbers, so I can relate to those ones. I pick A. Look at A to the power of 5 here. Look at A to the power of what? 3 here. So this will be A raised to the power of, and what is they are dividing. So if I divide them, it will be subtracting their indices. So this will be 5 to the power of A to the power of 5 minus 3. I come to B. This is B. This is B to the power of -2 divided by B to the power of 2. So this will be what? Minus 2. I'm picking them individually now. Okay, let's look at this. I picked this, I picked this, and I picked this. So this is what they are going to have. Now, what's the next thing you do? 5 can divide this, I'll get 9. 5 can divide this, I'll get what? 25. So I'm going to have 25 over 9, A to the power of 2. Because 5 minus 3 will be what? 2. I'm owing 2 naira, and I'm owing another 2 naira. That's what this one means. -2, -2. That will be giving me -4. That will be raised to the power of -4. Now, the concept of square roots, when it comes to an index, is that it halves it. If there's grammar allowed like that, it will cut it by half, or cut it into 2 and then take 1. So, what is the square root of 25? 5. What is the square root of 9? 3. Half of 2 is what? 1. Half of 4 is what? 2. So that will be B raised to the power of -2. Get this again. Square root of 25 is 5. Square root of 9 is 3. This A raised to the power of 2 square root means what? The square root of A times A. And when you, if you remember your grade 7, your grade 8, when we talk about solving by method of, what's that method again? Finding the square root by method of factorization. You discover that square root means write and pick 1. Write and what? Pick 1, or pair and pick 1. So the square root of A square means pick 1, spread and pick 1. So that's it, A. If I have B raised to the power of -4, it will mean I have what? B raised to the power of -1 times B raised to the power of -1 times B raised to the power of -1 times B raised to the power of -1. 4 of it as occurred there. So pair, pick 1. Pair, pick 1. And the pair is always 2. So in this setup, you discover that it is what? This times this. And what's your answer here? B to the power of -2. So what would your final answer be? Remember that you need to write this in positive in the index. If I have A raised to the, if I have, let's say X raised to the power of -1, it will mean what? 1 over X. So by implication, if I have X raised to the power of -E, it will imply that it's what? 1 over X raised to the power of E. So with that knowledge, I can come here to say 5a, having no issue, over 3, and then I bring b squared. That's the final answer to that question. So I think that's the only question we have there. Let's confirm. Yes, I'm spot on there. That's the only question we have there. So we can go to another question. Another question. All right, so that takes care of that one. And let's go to another here. I was trying to respond to the chat I was having from the YouTube. Okay, we go to another one. This one will now be, this is NECO again, and I think this is NECO GC. This is NECO 2003 November, I think. And then this is question number 1B, and it is what? Also theory. 2003, I hope I'm right with that. And this is also what? Theory. The question is a very interesting one. It says we should simplify 5x squared times, and this is times, so this is times 3 raised to the power of -1, x raised to the power of -3, divided by 5 raised to the power of -1x. So this is x, this is x, this is x, this is times. So how do you solve a question like this? How? Whenever you see a question like this, you need to be careful to write the question well before you start solving. These are some of those areas where you can end up making a very big mistake. So this will be equal to what? This will be equal to what? Now watch. 5x times this 1 over this 3 raised to the power of -1 will mean what? 1 over 3. I'll put a times. I want to spread it out. This x raised to the power of -3 will mean what? 1 over x what? Cube. Now, divided by what? 5 raised to the power of -1 will mean 1 over 5 times what? X. Notice what I'm doing. I'm not in a hurry. Whenever I see questions like this, I try not to be in a hurry, because if you hurry, you're going to make a lot of mistakes. Now, my next line, I'm going to have what? 5x times, these two are denominators, so I can say 1 over 3x cubed times, I'm going to change this to times, and I will relate all of this together. This is a numerator, this is a denominator. Okay, sorry, be careful, be careful. This division is only affecting this one. Sorry about that. It's only affecting this one. Let's be very careful. It's only affecting this one. So that will be 5 over 1, if you choose to say that, times what? X. Right? Now, after you have done that, if they wanted this division sign to affect this, they will put it in brackets. Remember your bid maths, depending on what you're using, either bid maths or board maths. You have to be very careful when you are doing that. You must always divide before you multiply. If they want the division to affect this, they would have put it in brackets. So that's why I say a question like this, you have to be very careful. Now, the next thing you do is to try to put everything out now so you can see. This will be what? 5x times 5x all over 3x cubed. So it is very clear now what I'm doing. 5 times 5 will be 25. X times x will be x squared all over 3x cubed. So what do we do next? This will be 25 over 3. Number. You isolate the number out first. Then look at x. This will be x squared. Because this is this divided by this, it means you should subtract their indices. Remember, if you divide numbers, technically what you're doing to their indices that you are subtracting them, right? So this will now give you what? 25 over 3x raised to the power of -1. Now, you can leave your answer like this, or you can further solve this to be what? You can now bring this x raised to the power of -1 means that the position of x is that of a denominator. Is that of a what? A denominator. So that will now be what? 25 over 3x. So see how we started? We're very, very careful. Division is only affecting this. Please take note of that. Take note of that. Take note of that. Right? Okay. All right, so that takes care of that problem, and I think we are done with that. Okay, all right, so that takes care of that problem. All right, that takes care of that problem. Now, please remember that you need to be very careful. This is where I know a lot of students are going to commit some real great blunder. This is where I know you're going to commit very great blunder. So you need to be very, very careful how you solve these points. All right. Okay, so we take that, and then we move to our next question. Please, I'll take all questions at the end of. Okay, fine. Thank you very much. Thanks for the observation. Very, very correct, Matthew. This is squared. Thanks for that observation. Thanks for that observation. This is squared. I wonder why where my square ran to. This is squared. You are very correct. Thank you very much. This is x cubed. Beautiful. This will be cubed. And this will be what? X to the power of what? 0. Beautiful, beautiful. And what is x to the power of 0? It is what? 1. So that fine means that the final answer becomes what? 25 over 3. Thank you very much, Matthew. Very, very good observation. Now, it is these observations that are very important in the class. It tells me that, yes, I have students who are following me. If you watch carefully, I lost it here. And these are the kind of things that can happen in the examination hall. After solving, you say you have killed the exam. You don't know that the exam has there's something you did not see. Next question. Thank you. All right, let's give us a little while to catch our breaths, and then we'll go to the next question. Right. Maybe this will be the only one we can take, as time is really, really running out on us. Okay, so because of the length of that problem, I want to wait. If you're okay with me cleaning the board, just a yes will do. A yes will do. A yes will do. All right, thank you very much. All right, thank you very much. Thank you very much. Okay, that's good. All right. So I'm going to clean off everything now. I'll clean off everything so that we can, I think this may be the only question paper we'll be able to take today. This will be the last question paper we'll take. But I promise you, I will solve the other ones and I will post to my channel much later so you can make out time to watch. I've already done a compilation of the log reading questions. I'm going to solve them and then you can make out time later to look at them in my channel. All right. Okay, so let's look at this. This is NECO 2021. This is the June edition, I think, and it is OBJ. It's OBJ. So let's look at question number 3. Question number 3 says 1/81 all raised to the power of negative half all over 0.3 times 0.09 all raised to the power of half. Okay, 1/81 all raised to the power of negative half all over 0.3 times 0.09 all raised to the power of half. Let's see. All right, now, in solving this, look at this negative. This negative means the reciprocal of this content. And what does the reciprocal do to a content? It turns it. It has the ability to turn a numerator to become a denominator and a denominator to become a numerator. It turns a fraction to a whole number and a whole number to become a fraction. It turns an improper fraction to become a proper fraction and a proper fraction to become improper. So understand what a reciprocal does. All right. So if you understand that, this becomes what? 81 over 0.3 times. Look at this. 0.09. What is the square root of that? Remember that half means what? Square root. Now, for me, who has a strong knowledge of this thing, I'll simply go ahead to say 0.3 because I know. My knowledge level says I know what this is. So I'll just cancel out straight. And my final answer becomes what? 81. And that's that for that. I don't need to waste my time. Implication, this is square root. All right, there's something I left out. Sorry about that. Thanks for observing that. Remember that I had a half here. I didn't apply that too. So please take note of that. I didn't apply that. So this will be half. So this will be 81 all raised to the power of half. And this becomes what? 9. So let's run that again. The negative only turns the content, but there's still a half. The half means find the square roots. These two will cancel out. And then the half means find the square root of what? 81. And that will be what? 9. Matthew has made it to become extra careful now. Thank you, Matthew. All right, so let's see. There's another question like that. Okay, there's another one. That same year, question number 4. It says 0.027 all raised to the power of 1/3 times 0.09 all raised to the power of what? 3, negative 3/2. Negative 3/2. Before you start solving this question, look at the way the answers are being presented. Before you start solving, look at the way the answers are being presented. It's very important that you look at the way the answers are being presented. So when I want to solve, the first thing I need to do is to convert this to a fraction. Because the answer there is not in decimal. So if I solve with decimal, I'll run into problems. So this will be what? 27 over how many zeros? 1, 2, 3. So that will be over 1,000. Everything raised to the power of 1 over 3 times. What is this one? This is 9 over how many movements restores it back to a whole number? 1, 2. So that's over 100. Everything raised to the power of negative 3 over 2. What does negative do? It toggles, it turns it. Now, this will be equal to what? 1 over 3 means what? Cube root. What is the cube root of 27? It is 3. What is the cube root of 1,000? It is what? 10. Times. Toggle this. The negative means turn it. The proper fraction becomes an improper fraction. And that will be 100 over 9. Everything raised to the power of what? 3 over 2. Now, this is what? 3 over 10 times. Look at this 2. I hope you know that this 2 means find the square root first before you find the cube. So I'm going to write this. The implication of that is this. Square root, then find the cube. So that done, this will be 3 over 10 times the square root of 100 will be 10, and the square root of 9 will be 3. Everything raised to the power of what? 3. Now, what do you do at this point? What do you do at this point? Now, there are different ways you can go about this. At this point, there are different things you can do. Well, let's see what I will do. Now, I hope you know that I can. Do I go with that pattern? No, let's not go with that pattern. Let's pick each one. This one means 3 raised to the power of 1. How many 3s do I have here? 3 times 10 raised to the power of what? How many 10s do I have here? 3 minus, this is a denominator, 1. So this is numerator, 3 raised to the power of 1, or then this is 10 raised to the power of 3. This is denominator means positive. Sorry, numerator means positive and denominator means negative. But let's assume that that appears to be a little difficult for you to process. So I can open the thing up. So let me open it up. Let's assume I have varied learners in the house. So what does this give me? Now watch. So what would this be? 100 over 9. But remember that the question did not say 100 over 9. This will now be what? 10 over 3, all raised to the power of what? 2. Now, there is no answer like that. There is no answer like that. So what do you do? Because sometimes there are questions you get in the hall and it will confuse you. There's no answer like that. 10 over 3, all raised to the power of 2. It's not in the option. So what do? I will now forcibly turn it. And because I am forcibly turning it, I am doing what is bad. And bad is what? Negative. So I will turn it by force. And this will become this. And if I do that, I will now see the answer. I want to pause a while so you catch what has happened. I've turned it. You understand how we got to this point? Now, how do we move from here to here? We'll turn this. If I turn this, I'm trying to make what is not to be. It's a negative movement. So that will not be reflected in reciprocal. So it's like saying the reciprocal of 3 over 10 is 10 over 3, or the reciprocal of 10 over 3 is what? 3 over 10. So that takes care of that question. Okay, so I think that is much we can take since it's already 9 o'clock. So like I promised, I'll solve the remaining questions under indices and logarithm, and I'm going to post on my platform. But just to clear the doubt, if we have 1 or 2 questions before we go, maybe we can entertain them. A question or 2 before we go. Can we entertain them? A question or 2? Okay, do me this favor. If you're in grade 10, just indicate grade 10 in the chat. If you're grade 11, indicate rather grade 11 in the chat. If you're grade 12, indicate grade 12 in the chat. Could you do that for me? If you're grade 10, indicate grade 10 for me. If you're grade 11, indicate grade 11. If you're grade 12, indicate grade 12. Also do that for the chat on the YouTube channel so that I can have a perspective of the audience that I had for today's class. No, not your name, your grade. Not your name, I want your grade. Either grade 10, grade 11, grade 12, meaning SS1, SS2, SS3. Thank you, Sotonye. Beautiful, beautiful, beautiful. Can we just do that quickly? Now, if you have other issues in the course of this class, I know maybe there are some issues I may not have been able to handle. You can chat me up privately. (006), maybe I should drop that on the chat. So you can chat me up privately, and then I will be more than willing to attend to other issues. Let's see, 006 485 7933. I've sent that. I've sent that. So if you have other issues, you can send them to me privately, or maybe perhaps you had a feeling that maybe we would have solved using another method. Beautiful. That's maths for you. I've always told you that what you do in the examination hall is a function of what you remember. And I was careful tonight not to use methods that will confuse us. Like if I'm taking grade 12, there are things I will not talk about. But I assumed that I had 10 to 12, so I needed to rearrange. Yes, we can do that. I've seen your question. How do we explain this to someone who is in basic 5? That's in primary school, is that not? Yes, we can do that. We can do that. We can explain that to somebody in basic 5. And the language I'm going to use will be very, very different. I'm going to use things that he or she will be able to play with. He's playing and he's getting the knowledge right. Okay. All right, so I'll release us now. Thank you very much. Hope to see you tomorrow by 8 o'clock. Good night and God bless.